Hello guys, we are back with another live stream, and as always today we'll be solving some good pattern based DSA questions. Yeah. So last time mm, we solved based we solved 7 patterns, and today we'll be solving more 7 patterns that we so that we'll be completely finished with all the patterns, and then we can go random questions, and then we can pick any questions and solve any question. And also one more thing, today we have a lead code contest at 8 p.m. So write down in the comments who all are excited for the lead code contest today. So I'll be giving the contest also today. Okay. So I think we are very much ready with the with our sessions. Let's try and let's start. Let me start my promo focus. Where are you? Okay. So as usual, today also we'll be solving for 50 minutes, and then we'll take a short break for 10 minutes, and at 1 p.m. We'll take a long break of maybe of 50 minutes or 1 hour, depending on the situation. Whether the cook has arrived or not. So I'll tell you that later. Okay. So let's just start our timer and let's start coding. So we started from 1 to 7, right, last time. Let's start from bottom this time and we'll go to top. Yeah bro, breaks are important, so that you can get an idea that when I'll take a break and when I'll not. Okay. So last time we solved very good questions based on few patterns that we discussed. Let me just go over the patterns that we had gone through already. And so we went through the sliding window. In the sliding window, there was a question that I suppose was a really impressive question. It was even medium level question, not hard level question, but was good. Now we discussed also two pointer and iterators. That was also good. We discussed fast and slow pointer. We solved a mini question based on fast and slow pointer also. Then we moved to merge intervals. We solved few good questions based on merge interval also. Then we went for cyclic sort. We solved cyclic sort also. So it was really good. If you want to solve some questions of cyclic sort, you must go through this cyclic sort. And then when in place reversal of linked list, this was also what we did. And at last we did tree BFS. We stopped at the tree BFS. So from today I'll cover tree DFS also. So let's not start with top, let's go from bottom, and let's see what all comes up this time. Okay, so we have a topological sort with us. So topological sort is used to find a linear ordering of elements that have dependencies on each other. For example, if event B is dependent on event A, then A comes before B in topological ordering, of course. Okay. So if there is a dependency from A to B, then B will come first, then A will occur, because A is dependent on B. This pattern defines an easy way to understand the technique for performing topological sorting for a set of elements. So the pattern would like this. works like this. So let's see the pattern. So the pattern says first we need to do the initialization. Okay, this is basically based on topological sort is something which is used in mostly in graph, say, or tree. So the initialization part, here we can store the graph in adjacency list by using a hash map. Okay, we just have to create a graph over here using a hash map. Let's just create a graph and let's see what let's suppose we created a random graph. From 0 I can connect 1 2 3 maybe let me draw a graph. 1 2 4 5. Let's suppose this is our graph, and based on this, what are the dependencies that we can see? From 0 we can go to 1, nowhere else. From 1 we can go to 2, and we can go to 4, and 5. From 5 we can go to 4. So this is what my graph is. So this is my hash map where we have key and value together. So to find all sources, use a hash map to keep the count of in degree, build the graph, and find in degrees of all vertices. So we need to find the in degree of all the vertices. So for finding in degree of all the vertices, what we can do is we can create we can create a map, or we can create a vector array of indices 0 1 2 3 4 and 5. So we can see there is no in degree. For initially everything will be initialized with 0. Now we can see that here there is no incoming arrow at 0, so it will be 0. Now for the next, for 1 there is a incoming arrow that is from 0. So for 1 there is one incoming arrow. For 2 there is one incoming arrow. For 4 also there is one incoming arrow. No, for 4 there is two incoming arrow. For 5 there is no incoming arrow. For 3 also there is no incoming arrow. So we can see that for 1 there is one incoming arrow. That means this will mean what? For completing 1 I have to complete 2. Then only will be able to complete 1. For 0 I have to complete 1. So it's going something like that. So now what we will do is we will find all the sources. We'll keep it in some queue. All the vertices whose in degree is 0. That means we can see the in degree value. This is my in degree array. So all the vertices whose in degree is 0, I'll keep it in my queue. So I can see 0 has an in degree of 0, 3 has an in degree of 0, 5 has an in degree of 0. So we kept these all values in the queue. For each source, do the following things. Now what we need to do, let's see what should we do. Add it to the sorted list. Okay, we picked this, we add it to the sorted list. 0, maybe this is my sorted list. So 0 we added in our sorted list. Get all of its children from graph. Decrement the in degree of each child by 1. If the child's in degree becomes 0, add it to the sources queue. This is my sources. So what I'll do, I'll pop this 0 out from here. I'll keep it in my sorted list. I'll check who, who all are dependent on this. So one has an in degree of 1. I'll reduce the in degree of 1 to 0 because I'm removing this 0. So we know that there is a in degree of 1. 1 is having an in degree of 1 which is coming from 0. So I'll reduce it. Now 1 has an in degree of 0. So what it's saying that when its in degree becomes 0, if the child's in degree becomes 0, add it to the sources queue. So I'll add 1 also in our sources queue. So 1 is added in my sources queue. Now there is no more dependency, so we'll move to the next one. Now 3 comes, we'll add it to the sorted list. 3 there is no dependencies, so we'll leave 3 as it is. Even we have to skip 3 because there is no node 3 available, so we can directly skip 3. That's why it was saying that we need to use map here. Okay, so we will not push 3 because it is not available in our graph. So the next one is 5. We'll pop 5 and we'll push it in my sorted list, and we'll see who all are dependent on 5. There is an in degree going to 4, so we'll reduce the in degree of 4 to 1, and still now it is not 0, so we'll not push this in our queue. So the next one is 1. We'll pop this one and we'll push it in my queue, and 1 is dependent on 2 and 4, so 2's in degree becomes 0, we'll push it in my queue. 4's in degree become 0, we'll push it in our queue. Now 2 I'll pop and I'll push in my sorted list. There is no in degree, it's also already 0. Now 4 also, there is no in degree, so we'll add 4 here, and there is no in degree, so okay. So now whatever our result came, so we need to do this until our queue is empty. We can see that 0, 5, 1, 2, 4, 0, 5, 1, 2 and 4. Okay, so is this even a sorted list? Because they had a in degree of 0, so they were in my sorted list first, and then comes in degree of 1, then comes in degree of 1, and then comes in degree of 2. Okay, let's see what it is saying, how to identify the topological sort pattern. Let's find it. The problem will deal with graph that have no directed cycles. Okay, there should be no directed cycles. Means there will be directed graph. Might be possible that there are directed graph, but there should not be any directed cycles. Means these this arrow should not be there, else this 0 1 2 will be a directed cycle. So we don't want this arrow to be there. If you are asked to update all objects in a sorted order, if we are asked to update all objects in a sorted order, okay, if you have a class of object that follow a particular path order, means it's saying that we need to find something which has some specific order, or maybe even in sorted or something else, but it should be in some particular order. Okay, so let's jump to a question of task scheduling. Let's see how also we can approach. So task scheduling, task scheduler. Okay, so it is saying that just a second. Okay, so we have task scheduler. Let's see. So we are given a CPU of tasks. So we are given a CPU of tasks, each represented by letter A to Z, and a cooling time n. N is our cooling time. Each cycle or interval allows the completion of one task. Each cycle or interval task can be completed in any order, but there is a constraint. Identical task must be separated by at least an interval due to cooling time. Task can be completed in any order, but there is a constraint. Identical task must be separated by at least n intervals due to cooling time. Okay, identical tasks must be okay. So here what we can do is, let's see how the question is approaching. See, we have been given tasks A, B, and the cooling time is 2. So the output is 10. Return the minimum number of intervals required to complete all tasks. A possible sequence is A, we do A, and then we do B, and then we remain idle for 1 second, then we again do A, then we again do B, and then we remain idle for 1 second more, then we do again A, and then we do again B. So total 1 2 3 4 5 6 7 8. So total second is 8 seconds. Now let's see the third example. What's there in the third example? The third example says I have I have 3 A's, 3 B again, and N is 3. So this time what will happen, I'll do A, and then I'll do B, 1B, and then I'll remain idle for 2 seconds. One, two, three. Okay. And then I'll do A, then I'll do B, then I'll remain idle for 3 seconds again, 2 seconds again, then I'll do A, then I'll do B. Will take 10 seconds in total. For me to complete. Okay. Do the ordering matters here? Does even the ordering matter? I'm not very much sure about the order. Okay, so what we can think of here, I have A, total count is 3. I have B, total count is 3. Correct. Now N is given 3 seconds. So either I can pick A or B. Is it going to affect? Or should I pick the largest one first and then the smallest one? Maybe suppose B's count was 5 and A's count is 3. So should we pick B first or should we pick A first? Even we can go for a B pattern, or we can go for a A pattern, like B then A then B then A, or then B then A, something like that. Or we can go for A then B, A then B, A then B, and again 3, 4 and 5. 1, 2, 3, 4 and 5. So which one will give me a lesser time? So if we go for B and then A, we'll have to sit idle for 2 seconds, and then again we can go for B, A, and then again 2 seconds, then also B, A, and again 2 seconds, then B, 1, 2, 3 seconds, and then B. So in total, how much time it will take? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. It will take 17. If I change the ordering, is it going to affect? We'll take A, B, and then 2 seconds. We'll take A, B, and then 2 seconds. We'll take A, B, and 2 seconds. We'll take B. No. We again have to take B. I'll have to go for 1 second more and then take B. Which will take 1, 2, 3 and then B. Okay, so 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So total it is taking 18 seconds. Correct, this is taking 17 seconds and this is taking 18 seconds. So this means there is some kind of dependency that we are facing over here. So in this case what we can do is we can pick the we should start with the one which has the largest count. We'll take that one first. because there is a fixed interval for each. There's no different interval for everyone. We uh, okay. And can be of 100 second. So one thing that we got is we need to start from largest, and we have a fixed pattern. You can see the pattern B A B A B A B B B A B A A B A B A B A B, something like that. So we have a fixed pattern, and already we saw that if there is a fixed pattern, a particular order in which we have to follow, we have to go for a topological sort. Okay, so how can we approach this question? If you guys have anything in your mind, do let me know. How can we approach this question? So what what all things that are coming in my mind is, I have suppose B S5 A S3, so we'll pick B. Now B's end interval, uh, there will be an interval that will end at, so the B's new end interval is at what should I say, we are starting from time 0, so T is my 0, so the new 0 1 2 and 3 at 3 second, at 4, so 0 plus 3 plus 1, that is at 4th second I can use B again. At 4th second I can use B again. Now if I use now T will be increased to 1. At 1th second I can 1 plus 3 plus 1, that is 4 5. At 5th second I can use A again, correct? So these will be reduced. Now at second, at time 2, is there any anywhere that I can see is empty? We have already consumed all. No. So we'll increase the time at 3. So at 3, no. At 4, yes, we saw B, we can use B again. So what we'll do, we'll reduce the B's count to 3, and I'll add 4 to it. Now next, at 8 second I can use B again. At 5, can we use A? Can we use anything? Yes, we can use. So at 5 we will use A again. And I can again use it at 9. At 6 we cannot use anything. At 7 we cannot use anything. At 8 we can use this. So I'll reduce this to 2. Sorry, I should have reduced this to 1 to 2, and 8 plus 4, that is at 12 we can use this. At now the timer goes to 9. 9 can we use this? Yeah, we are doing the same thing. We have to sort all the tasks based on frequency, and then we have to start with the highest frequency only. So I'm picking the highest frequency element first, and then we are jumping to next one by one. Okay, 430, and this is reduced to 0. If this is reduced to 0, I can remove this. I don't have to go. Like even directly, like we have B as 5, A as 3. B's frequency is 5 and A's frequency is 3. I have to keep it somewhere, the next time interval that it will occur again. So and then we can directly jump to that time instead of going one by one from time here to there. We can directly jump. So 5 we are starting so B at 4 will be free next. So we can even keep this in our priority queue, where we'll get the minimum at the top, so that we can directly jump. We don't have to do this one by one. So it will be something like that. We have a priority queue. So this is for B, this is for A. Just a minute, I think cook has arrived. Just give me a 2 minutes, I'll be back. I'm back. Uh, Task which has the highest frequency, then we can use the last used index position each task. Initially at all at -1, maybe current position. Okay. Current position minus last index position for each task can give cooling period.
अभी तक डिस्पैच ही नहीं हुई वो सी तो
Initially all at -1, maybe current position minus last index position for each task can give the cooling period. Okay. Priority queue can be better option, but not sure how it will be helping me reducing the time complexity overall. A priority queue will give me a time complexity of n log n. That is the maximum that we can do, and we have this uh, going till 10 to the power 4. So I think n log n will also be okay. I didn't understand this current position minus last index position for each task can give cooling period. ये वाला में confusion, ये एक बारी फिर से बताइएगा ना. T हम ले रहे थे current index, current position is suppose 4. Maybe what I was thinking of going with the priority queue part only, if I'll understand this or what you are saying, then I'll try that approach also. So now I'll take this. T is currently at 0. So this time plus 4 will be at 4, which is B. 4 at B, and then my index will jump here to the next one. We haven't completed all of them first. So we sequentially will will add all. So this will end at 1 at 5. A will end. Now we have already consumed A and B, which are there in present tasks. Now we can see that at the top of our priority queue is the shortest one where I can start again. So at 4, so we directly jump to 4. We see B is there, so B will be 4, this will be 2, so we'll reduce this B as 3 and we'll increase this to 8. Now at the priority queue top will be 5. This will increase to 5. So 5, we already have 5 plus 4, that is 9, will give me 9. And I'll reduce this as 1. Next is 8. I'll increase this as 12. I'll reduce this from, and then plus 4 will give me 13. I'll reduce this to 0. Now at 12, this has already been 0, so I'll remove this. From 12 plus 4 will give me 16. I'll reduce it to 1. And at 16, this will go to 20. Was maximum that we had. Keys 3, if I keep expected is 70, correct. Okay, so let's try and code this. What do we need to do? We have to keep the frequency at first. We know there will be a task from letters A to B, so I can create a vector frequency of size 26, everything will be initialized with 0. Task dot size frequency of tasks of I will be tasks of I minus a. So we can sort this frequency. Voice is very low. Voice is it okay now? Still low. Hello. Now also. Okay. So what we'll do, we'll sort all these on the basis of highest frequency. So frequency dot begin frequency dot end. So we sorted it on the basis of frequency. Now next what we can do is we just have to iterate over it and put everything in our priority queue based on n. So we can create a priority queue which will contain two things, pair, and it should be sorted in ascending order. So these the priority queue will be sorted in ascending order. Now what we need to do is we have to push all the frequencies whose values is greater than 0 into our priority queue. Maybe the sort method of greater was something like this. Yeah, okay. frequency of I is greater than 0, that means there it the frequency of I will be reduced, and in priority queue we'll have to push two things. We'll be pushing two things, that is from where it is starting and what value. So the second value will be I and the first value will be uh, the first one is we are picking as I, so it will be I plus n. I is 0 if it is 3, so 0 plus 3, that is 3. So we need to add one more, that it will stop at 4. So I is 0, so 0 plus 3, that will give me 3 plus 1, that is at 4th second I can use this value, and this is I which will say what index it is present. So total tasks dot so it will give me all the way. So while len minus minus and also we want one answer. So initially our answer will be what, uh, answer no it should answer will not be this. So I'll update I'll pop int time pq dot top. So I picked the time and the index. So t will be maximum of t comma so this is the first value that is going to be removed from here. That means we are using this again. So one thing that I need to know, that its value is greater than 0, then only we'll be pushing it. So we'll pop this element out, pq dot pop. Now if frequency of this index is greater than 0, then only will do something, else will not do anything. If its answer is greater than 0, then I'll update my answer as this time. Now its frequency is greater than 0. What we will do is we will reduce the frequency of this index and will push in our priority queue whatever time we have plus n plus 1 will be the new timing for this, and the IDX will remain as it is. And at last will return our answer. And this length will tell me that all the nodes are completed or not. Let's see what mistake are we doing. Okay. There is some mistake. I was expecting this mistake. Let's check with the first one. We have 3 A's and 3 B's. See, the only thing that I'm mistaking is updating the answer. I need to handle that part. I'm not handling that part correctly. So we have A's frequency as 3, B's frequencies as 3. So in my array there will it will be of 26 size. I don't care about any other. 0 and 1 will be filled with 3 and 3. So in my priority queue what will be, n is 2. So in my priority queue there will be 0. What we are doing is 0 plus 2 plus 1, that is 3 with 0 index. The next it will be updated. So then next is 1 3. So 1 plus 2, that is 3 plus 1 4. So it will be freed at 4, the 1th index. So 3 and 4 are at here currently, and also I'm reducing the frequency. So it's now 2 2. Now the next thing what we are doing is we are taking length. We know that the total, okay, So the total length is 3 plus 3, that is 6. So until and unless this length becomes or priority queue does not becomes empty, not tk dot empty, that would be better. If it becomes empty, still the answer will not be affected, no problem. So we have answer as 0 currently. Okay, so let's start. I picked the time, that is 3. I picked the index at 0 and I popped this out. So this is popped. Now the t is maximum of t comma time. I don't know why we are using this. Okay, for now t is 3. If its frequency is greater than 0, we are updating our answer also as 3. So we updated our answer as 3. I reduced my frequency. Its frequency is reduced to 1, and also I pushed it in my answer, that is time, which was 3 plus 2 plus 1. So 3 is 6 with index 0. So this has been pushed. Now my priority queue is not empty. We'll pick this 4. My time will be increased to 4. I'll pop this out. I checked if in frequency bar it is 2. I'll reduce this to 1. I updated my answer to 4. I reduced it. I pushed again with 7 as a frequency of 1. We saw 6. We updated our t as 6. We popped this. We updated our answer as 6. We reduced the frequency to 0 and we pushed 6 plus 3, that is 9 as 0th index. Again we have 7. We popped this 7, reduced the frequency to 0. It was greater than 0, so reduced, and then we pushed again. This will be updated to 7, this will be updated to 7, and and 7 plus 3, that is 10. 10 with 1 will be pushed. Now this is at 9. T will be updated to 9. We'll pop this out. This is at 10. Their frequency is not 0, so it will not be updated. So my answer is updated to 7. Correct. But it is expected that my answer should be 8. How and why it's coming out to be 7? Now we used A and then we used B. And then there is an idle situation. It's 1, 2, 3, 4, 5, 6. Oh, okay. The answer is 1, 2, 3, 4, 5, 6, 7, 8. So it's 1 based index. And I was using 0 based index. Even if I do answer plus 1 will fail the second case. see AB dB. Let's see the second one. Why we failed on the second test case. So A's frequency is 2, B's frequency is also 2, C's frequency is 1, 2, and D's frequency is also 1. So we see that AB, we can use AB and then C and then D and then again AB. So there is some problem in updating the answer. We need to handle how we are updating our answer. We are keeping in future. This will have when it came back. So yeah, 0 1 2 3. So my answer will be updated with maximum of answer and whatever time it is minus n. Do we have to subtract 1 also from there? No. Okay. Let's run this. We have some problem. Let's remove this T. We don't want this T. So what I am doing is 0 plus n, that is 1. Plus 1, that is 2. So if it is 1, it was 1 and I'm using A at 0. I can use A again at 2. I cannot use instantly. Correct. Okay. I can use this as 1 at 3, at 4, at 5. they are updated to 0 and 0, and this is 1, this is 1. So the minimum is 2. I can use this again. I'll remove this. Now what I'm updating in my answer is being updated with either answer initially has 0 or time minus n, time minus 1, that is 1, minus 1. It should be updated with minus 1 also. So 1, and then index plus 1, minus 1, and then answer plus. Time minus 1, that is still 0. Stay at 0. So answer this will be updated from 0, it will remain 0. Okay, now 2 plus 1, that is 3, plus 1, that is 4. So it will be updated with 4. 4 will come here somewhere with an index of 0, and this will be reduced to 0. Now for this 3 will be popped. 3 minus 1, that is 2, 2 minus 1, that is 1. So 1 will be, it will be updated with 1. 3 plus 2, 5. So it will come somewhere here. Oh. This will be reduced to 0. There is 2 4 4 coming over here. Okay, that's why the answer is coming out to be it means there is something wrong the way I am approaching this question. I should not approach it in this way. ACABDB. has been elapsed to 4. Instead of keeping it where when it will be in future, we can keep it. What other approach can we go for in this? What mistake? I mean, my maximum is 4. That means 4 seconds is consumed. I need to go for 5th and 6th for these two because the slot is not empty. How can we improve it? ECABDB. We can even do AB, then AB, and then CD. We can do AB, CD, AB. I don't want this to be iterated one by one and check whether 4 is available or not, 5 is available or not. If not, then go to 6th position. Don't want to do that. It will take a lot more time. Can we approach it with some other way? Can we okay, let's try and there are many different solutions for this problem, including a greedy algorithm. should be very simple. It should not be that this much difficult that we are thinking of. Now let's take current time. Current time will be at 0. So current time will be updated with 4 because we consumed these all. 0, 1, 2, 3. 4 values consumed, so 4 second has already been elapsed. Now at the 5th second we are coming back to this. This is 0, this is 0, this is 1, this is 1. So now at 5th second we are coming back to this value again. Now I need to check with my current time. Current time is 5 and the value going should not be. So whosoever will be maximum will be kept will be kept in our map in my priority queue. Okay, let's handle it with current time. Current time is 0. Current time is equals to I plus 1. Zero, 1, 2, 3, that is 4. So current time plus 4. Priority queue. Current time is at 5, right? So 2 0 was at 2, and this was at 1. Now my current time is 5, CT is 5, 2 plus 0, so time is 2, 2 plus 1, that is 3, plus 1, that is 4. So maximum will be kept as 4 and 5. So this will be popped 5 with value 1. This will come, this will be updated to 6. So I'm updating in my answer as time is 6, 6 minus 1, that is 5, 5 minus 1, that is 4, and plus 1 is giving me 5, but it should not. And that means I have to add n plus 1 over here also. Why I'm making it so complicated? I don't know.
बोलियो
952 क्या क्वेश्चन?
तो इसमें क्या है ना कि ये पढ़
Okay. I think I should see what I did is I kept an unordered map of character and integer map. I This is the frequency bar. Fine, we kept a priority queue, the maximum at the top. Hmm. We kept its frequency. We directly grabbed its frequency in okay. This priority queue is keeping its frequency, the maximum frequency at the top. Fine, that's fine. That's not a problem. Okay. Well, its top is not empty. I created a R time. Okay, what this R time is doing is starting from 0 till n plus 1 lesser than n plus 1. If my priority queue is not empty, so R time dot push back pq dot up. This for loop is doing was priority queue is empty. R time dot push back pq dot top minus 1 pq dot pop time plus plus. First count the number of occurrences of each element. Let the max frequency seen, and for each element we can schedule first m minus 1 occurrences of e. Each e will be followed by at least n CPU cycle in between successive schedule of e. Okay, how it is doing in so short. Unordered map. I created a map account. I iterated over tasks. I created the and I kept the max frequency. So this count will give me the maximum frequency of. So answer will be count minus 1 into n plus 1. v of second is equals to count. Oh my god. Okay. Some task again CPU has to wait for time, and therefore we can think of as if there is a cycle of time and plus one regardless whether you schedule some other task in the cycle or not. To avoid leave the CPU with limited choice of task having sit down cooling down. What exactly are we doing here? I'm keeping the highest frequency at the top, all time cycle and plus one. While priority queue is not empty, why we created a temp variable and pushing all the values in my temp and increasing the time. What it is doing is okay. The priority queue is not empty. What we did is we keep priority queue with counter 2211. What is my cycle? Cycle is n plus 1. Are we updating even cycle anywhere? No. So currently cycle is 1 plus 1, that is 2. So 0 it will go 0 and 1, though two times it will go. If priority queue is not empty, temp dot push back priority queue. So I pushed back to I removed this. I increased my time from all time. Current time is 0, so 0 to 1. Again we popped this and pushed it time to 2. So how many? This is my time. Now all for int count temp, if minus minus count. So I'll reduce it this. If if it is not 0, if it is 1, I'll push it again. I'll push it again. And if priority queue is not empty, so all time answer will be updated with अगर priority queue is not empty, then it will be updated with 2. So cycle all time will be updated with 2. As it will be updated with whatever value we have. We popped this on, popped this out. 2 again. No, 4. We popped this out, popped this out. Okay. What does this even mean? This is kind of some. This answer is not bad. Even I understood the answer, but still, this is not the optimal approach to any of the answer that we are doing. Can't we do this with the way that I am doing? Okay. Okay, no problem. I'll take a 10 minutes of break, and then when I'll come back, I'll try and solve this again. Just give me 10 minutes break, and I'll be back. I'm back. Let's start again. Let's see why we were doing mistakes. Are we thinking in some wrong way? Okay, the solution that is present in the editorial is, I can't see the editorial also because I don't have Prime. Oh, okay. It's a free editorial. Great. Okay, I don't want the math formula. Let's go for the greedy one. Let's try. Just a second. Okay, so let's try the greedy approach. So the greedy approach says the key is to determine the required number of idle intervals. It starts by exploring how to arrange tasks. It is apparent that a greedy arrangement works well. Always arrange tasks with the highest frequency first. The goal is to arrange the tasks with the highest frequency first, ensuring that they are separated at least n units of time. For instance, if the tasks are this, the initial assignment would be A denotes the implicit. Okay. The same approach can be applied to arrange B. Oh, okay. This thinking in this way is also great, isn't it? Now that we have a method of arranging tasks, the next step is to calculate the total number of idle intervals required. The solution to the problem is the sum of the idle intervals and the number of tasks. Consider the same example of task. After arranging A, we get this. Observe that A separates the empty slots into count of A minus 1 is equals to 2 parts. Okay, there is 2 parts, these and these, each with a length of n, each with length of 2. A has the highest frequency, so it requires more idle intervals than the other tasks to calculate parts, empty slot and available tasks. So find the number of parts separated by A, determine the number of empty slots. Okay, so find the number of parts separated by A, part count count of a minus 1. Determine the number of empty slots. Empty slot is equal to part count into n. Identify the number of tasks to be placed into those slots. Available tasks is equal to task dot length minus count of a. Now the remaining tasks are 3. So there are 4 empty slots. If empty slots is greater than available task, indicating sufficient task to fill all empty slots, the remaining slots are filled with higher interval. So idles will be maximum of 0 for empty slots minus available tasks. Will it go negative? Okay. How many empty are left? If empty slot is, we know that if empty slot is greater than available tasks, then why are we keeping maximum? If not, if suppose there are 4 empty slots and we have more to be placed, 2 C is also twice and D is also twice, so we have total number 6. A special case arises where there is more than one task with the highest frequency. For instance, triple A, triple B, double C and D. I'll arrange A. When arranging B, it becomes evident that B must follow each A, considering A, B as special tasks. X, the arrangement becomes A, B, A, B, A, B, and one slot will be reduced. In this case, the calculation of parts, empty slots and available tasks are adjusted. Created an array of 26. I moved through the task, I incremented the counter. That's fine. If maximum is equals to counter task minus A, max count plus plus. Else if maximum is lesser than counter of task minus A, that means maximum counter that we have is max count is 1. Calculate the number of idle slots. task represented by the same character are considered identical. Repeated tasks should be at least an interval apart from. Why do current time execution? Count the occurrences of each tile while prioritizing those with the highest frequency. We use a frequency map and max heap, where frequencies are sorted as negative values to simulate max heap behavior. In each iteration, a cycle of length n plus 1 is considered, signifying the time needed to execute tasks without violating the cooling period. For instance, if there are two tasks A and n is equal to 2, the iteration required would be A minus idle minus idle minus A. I'm picking one at a time and solving all of them, and then we are going to the new one. Tasks with the highest frequency are popped from the max heaping. In the case of frequency ties, we created a there is a cycle of n plus 1. Tasks count. Okay. frequency to the heap. To task and update the frequency. Create a priority key inside the frequencies. Initialize the variable. When the priority key is not empty, which represents the cooling interval plus 1 for the current task. For the current task, the cooling interval is initialize an empty array to store frequency of task that still needs to be processed. Okay, this is for the storing part. As we are going only till cycle, initialize a variable task count to keep track of the number of tasks processed in the current cycle. Why this is a cycle? Cycle is n+1. I'm storing it. That means A, B, and C. So priority queue has 3, 2, 1. And suppose is 2. So 0, 1 and 2, it will run 3 times. I'll pick this, I'll pick this, I'll pick this. That means it is saying that I have 3 slots and I can keep all these 3 values in these 3 slots. So I'll keep A here, I'll keep B here, I'll keep C here. And then we have suppose 3 slots again. So we reduced all the value to 2, 1, 1. We pick again. We make this is one cycle. Now there comes another cycle which has 2, 1, 1. So I'll pick again A, I'll pick B, I'll pick C. Now the frequencies are this is 0, this is 0, so we are not going to push it. Now we have still again we have 3 slots. And if n would have been 1, now let's understand this. Now I'm getting the intuition on how we are handling everything. So 0, 1. There is a cycle for this. So we popped 3, we popped 2, and we stored A and B here. So it will be 2, 2 and 1. So now this was A, this was B, this was C. So we pushed A, B, so this is now B, this is C, this is A. Now what will happen, I'll put A and C here in the second cycle, and its frequency will be 1, 1 and 1. Then it will put again A and C here. Now it will put B here, And if there was an idle situation, what would have happened? Then we have added direct totals. Okay, I understood it very clearly. We are making a cycle of intervals. If n is equals to 2, then we are making a cycle of 3 size, and each will contain a value. Each will contain a value or task. Push. So there is a there will be a cycle. Let's just remove this and try to solve it on my own. Cycle will be what? Nothing but the slots available. Each time, what slot are we picking? So in this slot, how many values can we fit? So this will give me how many values we can fit. So while not pq dot empty, okay, I'll make a for loop of int I is equals to 0, I is lesser than, and count is 0, I is lesser than plus I. Now if not pq dot, if my queue is not empty, so what I will do is store dot push back pq dot top and pq dot pop. And my count will be increased. Now my answer will be something if my PQ is not empty. Means what? If there are still values, so I'll iterate over this store. If store of I, if minus minus store of I is greater than 0, then tq dot push store of I back again. Answer will be if not pq dot empty. If priority queue is not empty, then we'll add cycle, else we'll add count. And this time it works. That means we are filling slot by slot, slot by slot. It's a great question. It's a great question to we should try. I'll mark this. Okay, let's try and go with another question. It was a good question, topological sort. Next question is minimum height of a tree. Let's see, what is this? Height of, not minimum height. So it is saying that a tree is an undirected graph in which any two vertices are connected by exactly one path. In other words, any connected graph without simple cycle is a tree. Given a tree of n nodes labeled from 0 to n minus 1 and an array of n minus 1 edges, where edges I is equals to a of I comma b of I, indicate that there is an undirected edge between the two nodes ai and bi in the tree. You can choose any node of the tree as the root. When you select a node x as the root, the result tree has height h. Minimum height trees. Okay, let's understand the question a bit more clearly. Given a tree of n nodes labeled from 0 to n minus 1, 0 to n minus 1, okay, an array of n minus 1 edges indicates edges between ai and bi. There is an undirected edge between the two nodes ai and bi in the tree. You can choose any of the node of the tree as the root. Okay, I can choose any of the tree node as the root. When you select a node x as the root, the result tree has height h. Among all possible rooted true, those with minimum height is called the minimum height trees. Return all the list of minimum height trees root labels. You can return the answer in any order. I have to return. So there is an edge between 1 and 0. There is an edge between 1 and 2. Then there is an edge between 1 and 3. the return the list of all minimum hide tree root labels. You can turn the answer in any order. Okay. Let me draw this graph. This is saying 3 0. 3 is connected with 1. 3 is also connected with 2. 3 is connected with 4. And 5 is connected with 4. So there always be the answer will be either two edges, two vertices will be there, or one vertices will be there. So there will be only two possible answers. So if I see all those node who has no incoming edges, I can go from here to here. If their edges become 1, I'll put it in my answer. So the edges are 4 and 3. Correct. So this is not this will not be very hard this time to solve this. I hope so. This will not take much time to solve. Just give me a minute. I'll be back in a minute. Back. Sorry, got a call. Okay, so we are solving this question. So what we need some kind of in degree to handle. It's already given. There are these edges, 4 edges. So I see lesser than edges dot size plus I. Now what we need to do is we need to add it in our in degree, and also I need to create a graph. Let me create a vector int graph of size n+1. Edges of I. So g of edges of I of 0, push back, and this same thing, because this is an undirected graph, so we need to push from both side, else we won't be able to. And also I need to increase my in degree of both edges. uh, 0 and 1. So we created a graph, we also created the in degree for this. Perfect. Now what we will do is we will have some kind of data structure that will help me in storing the values. So what we will do is we will have some kind of data structure kept over here. Let's keep a queue. We don't want any priority queue. We don't want to prioritize things based on values, because values won't be helping me here. The the thing which is going to help me here is the edges, which is nothing but the in degree of all the thing. So that is going to help me, and but not the values. So I'll keep a simple queue. I'll iterate over the in degree, because it is a 0 based index, so I'll start from 0th index only. If the nodes, if the edges would have been, vertices would have been starting from 1 based index, then I would have started from 1. So if q, if in degree is of I is equals to 1, that means we are pushing all those values whose in degree is 1. That means that will be the leaf nodes. uh, so I'll push in my queue that value, that I. Need help. Yes, Utkrish, tell me. How can I help you? So while not q.mt, okay, no. While n is greater than 2, while n is greater than 2, I need to I'll do what? I'll pick this node out from my queue. Q dot front will contain the node. I'll pop that node. Now I'll iterate over all its child node. So their child nodes will be all of these. What I will do is I'll reduce from my in degree of this new node. So let me create a new node which is nothing but g of node of find help me finding mistake. In which question are you saying? What type of mistake are you facing? This is my new node. In degree of new node, I'll reduce it. I have to reduce it. So if minus minus of in degree of new node comes out to be 1, that means that will be a leaf node. So I'll directly push in my qq dot push and I'll reduce my node. So I have to create vector int result now, while not q dot getting TLE by union find. Can you tell me the question? Which question are you approaching? Let's see. Let's solve that question also. Result dot q dot front q dot let's see if I'm right or wrong. Okay, 3 and 4 is fine. For this it is coming. $952. Please go through the link of my solution. Share your link. Yeah, there is a delay. It is added by default by YouTube. I am not doing any kind of delay here. It is added by default. Okay, let's see what the first I have from 1 to 0, from 1 to 2, and from 1 to 3. If in degree of I, so in Q it should be 0, 2 and 3. All three values should be pushed. Uh, 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 uh. If it's in degree of new node is 1, I will push this new node in my queue, else I'll not. And while my queue n is, okay. Now I know the mistake that I'm doing. Length is equals to, okay, now it's 1 and it's 3 and 4. Let's submit it and see if it is, if I'm able to submit it or not. But if there is no edges, I have to return 0, because it's saying there is one edge. Okay, if AD edges dot size equals to 0 and n is greater than 0, in that case I'll have to return this. Even if n is 2, 3, 4, doesn't matter, there is no edge. So 6. Okay, great. That was one of the edge case that I needed to handle. Rest is perfectly fine. So there will be only 2 edges in my answer. So we have to boil it down to center. It is saying that the minimum height tree. So this uh, in the last lead code, I would say uh, contest, where there was a question based on tree. Fourth question, the hard problem. The concept was very much similar to this minimum height trees. Okay, so this is nice. So we finally we were able to handle this topological sort. This question gave me a hell of a time task scheduling, but finally I got to know how to approach this question. So this topological sort is fine. Now we can go with K-way merge. Utkrist, can you share the solution link that you are doing? Okay, we will go with question 952 also. Uh, let's see. 950. Largest component size by common factor. So it is saying that we are given a positive unique integer. Consider the following graph labeled nums of 0. If nums of I and nums of j share a common factor greater than 1. Okay, let's take a 10 minutes of break, and after that break I'll try and approach this question. Okay. Okay, so we are back. Let's go. So so we have a question that is we need lead code 952. Let's see lead code 952. So the question is saying we need to find the largest component size by common factor. So there will be an undirected edge. So the question is we can see 4 and 6. We are given few nodes, that is 4, 6, 15 and 35, and we have a common factor between them which is not 1. So those are 2. They both have only one common factor, that is 2. They both have one common factor, that is 3, and they both have one common factor, that is 5. So you can see they both have 2, they both have 3, it has 5. So that's why they all are connected with each other. Now if we follow the same rule with the second one, we can see 20 and 50, they both have a common factor, maybe 10. 10 is or 5, both are same, both have the common factors. Now they both have common factor as 9 or 3. Correct. So either they have 3 or 9, but neither of them has a common factor between them. I cannot make a common factor between them, neither between them and nor them. So they both are disconnected, they both are separate components. So in this case what we need to do, we need to return 2, that is the maximum component that I can create is 2. So how can we approach this question? So we need to find maybe the third question is very complex, confusing, but they all are connected with each other, that I can see. There are common factors between every node to every other node. So let us see how we can approach this question. What we can figure out about what 4 can have. 4 has a common factor which is not 1 and not the number itself. I'm not considering them both. So we are neglecting these and accept these. What is the common factor? That is 2. 2 is one of the common factor. 2 can divide 4 and not 3, not 4 we are not considering, 1 is we are not considering. So we have a common factor 2. Now for 6 we have a common factor 2 and 3 except 1 and 6. For 15 we have a common factor which is 3 and 5. For 35 we have a common factor which is maybe 5. So this is what we can see. We have 4, 6, 15 and 35. Now how to approach this question. So for approaching this question we might need few more things. So we can see there are some common factors between them. See, there are common factors between them. There are common factors between them. Now we need to connect them based on their common factors. So how can we connect them based on their common factors? So in this case we can uh, use to connect. We can connect them maybe on the basis of some commonalities, and some commonalities we have to unite them together based on some commonalities. So the commonalities is the common factor, and for uniting we can go for union and find approach here. So based on some commonalities we are going for union and find approach. So let's try and do some union and find method. How can we do it? So if we know that the possibilities, the common factors present over here are 2, 3, 5, on the basis of that we need to connect 2, 4, 6, 15 and 35. So let's create an array of maybe of 35 size. And what is the maximum that we can go? The length can go up to 2 into 10 to the power 4. That is the maximum that we can go. So suppose this is we are reaching till 35. We have 15 over here, we have 6 over here, we have 0, 1, 2, 3, just a second, 3, 4, 5, 6, 15 and 35. This is what we have in our array. We'll create an array of size 35. Now what is the common factor? We'll connect this based on their common factors. So we have 4 as a common factor. 4 we can see 2 is one of the common factor for 4. So 2 and 4 we connect 4 with 2. So initially the parent will have their own values, 15 dot 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 35 till 35 they'll have their own values. Now 4 and 2 will be connected. So 4 and 2 let's connect it with something. Some other value. So connected with 2. So 2 and 2 both are connected. Now 4 has no other factors left. Now 6. For 6, 2 is one of the common factors. So 2 and 6 can be connected with each other. So based on the ranking, I'll choose the parent of this. So this parent will be 2. Now 3 is one of the also the common factor. So 3 and 6 will also be connected, but based on ranking, this 2 has more rank than this 3. So this 3 will be updated with this 2. Now for 15, we also have 3 and 5. So for 15, we have 3 and 15 will be connected with each other. So 3, this 2 has a more ranking than 15, so we'll update this with 2. 2 and 3, 5 and 15 will be connected. Whosoever will have a more rank will be connected with. Now 35 and 5 will be connected with each other. 35 and this has a and also 7 will also be connected, and 7 and 35, so 7 will also have a 2. So there will be somewhere 7 in between. 7 parents will also be 2. Now we will iterate over this 4, 6, 15 and 35. Now 4 parent is 2. So 2's count is 1. 6 parent is also 2. 2 count increased to 2 2. 15 parent is also 2. 2's count increased to 3. 35 parent is also 2. So 2's count will be increased to 4. So total 4 are there and 4 will be returning answer. So this is the approach how we'll be solving this question based on parent and ranking, union and find. Let's try and create union and find for this. Let's create a separate class, maybe union find. Let's call this union and find. This class will contain few things in public. This because we need to access parent and we need to access rank. So everything will be public for now. I can even make it private, but I'll have to increase the function. So I'm not going to use this. Even I have a class. Why to create a separate class for union and find? It's just not created. Let's use here only. So let's declare a vector int parent vector int rank. Rank, let's take it long because rank always has a greater value. Now so I'll take a max element because I have to create a parent of size of the max element. So max underscore element nums dot begin nums. Nums dot begin comma nums dot end. So I'll resize my parent from max element plus 1. Don't initialize with anything, but rank will be resized with max ele plus 1 and will be initialized with 1. Everyone will have its own ranking. Now I'll iterate over and I'll update parent of I with I because initially their own parent will be they themselves, so we don't have to create anything else for that. Now what we will be doing is we will be iterating over the array and we need to find the factors. So for finding factors I don't have to find 1 as a factor, so I'll start with 2 and j will be lesser than is equals to square root of the nums of I. Is finding common factor. If you don't know, you can ask it in the chat or even you can check on you any GFG website, like how to find the common factors using square root method. So you'll be able to get. So I need to create two method. One is union and other is find. So let's create union. It'll return nothing. It'll just unite the two values. Int x comma int y, and find will return something, int x. So if parent of x is equals to x, return x. Oh, so were you doing mistake on finding the square root? Is it so? Common factors. Return parent of x is equals to find parent of x. So this is my find. Now for union part, I need to find the parent of both. Let's take it, consider as a and b. So x will be find a, y will be find b. So x and y. Now what we need to do, we need to merge it on the basis of rank. So if rank of x is greater than rank of y, that means x rank is greater, so parent of y will be x, else parent of x will be y. Square root j is equals to 2, j is lesser than square root of nums of I. Now we need to unite them. So union nums of I, that is this with its common factor, that is j. Okay, before uniting we need to check that whether it is a common factor, even a common factor or not. So nums of I modulo j, if that equals 0, that means this is a common factor. Now I can unite them. Even I can unite the second value, that is nums of I divided by j. So they both will be the common factor. I'll unite both of them. Now I've already united, so I'll create an unordered map. Frequency or something. What this first will store common factor, and the second part will store its count. Now I'll iterate over now frequency of I need to find its parent. So if I'm finding the parent of nums of I, and increasing it. Or maybe let me just find parent parent value is equals to find of nums of I. So I can directly do frequency of this. I need to keep an answer variable, maybe int result is equals to 0. So result will be maximum of either result or frequency of parent val. And finally I'll return result. Let's see if I'm doing any mistake. Okay. Okay, great. It's working fine. Let's submit it and see if everything is correct. Great. So we are able to solve this question. So this question is really nice. If you understood the logic behind this question, then you'll be able to solve this question. But if you did not, then it'll be a really hell of a task to understand how to solve this. Cool. Okay, so let's go for K-way merge. Next up approach is our K-way merge. So this K-way merge helps you to solve problem that involve a set of sorted arrays. Whenever you are given K sorted arrays, you can use a heap to efficiently perform a sorted traversal of all the elements of all arrays. You can push the smallest element of each array in a mean heap to get the overall minimum. After getting the overall minimum, push the next element to the same array to the heap, and repeat this process to make a sorted traversal of all elements. So we are given a given linked list and three list. All the three are sorted. We need to create a sorted linked list, resultant linked list. Okay. K pairs with largest sum. Maybe let's try this one. K pairs with largest sum. Okay, this has the smallest sum. K pair with smallest sum. Okay, it'll be very much similar. Merge K sorted list. Thank you, Sugam bhai. ये एक सेकंड हम बोल रहे थे So the question is saying that we are given a k linked list. Each linked list is sorted in ascending order. Merge all the linked lists into one sorted linked list and return it. So we need to merge all the sorted linked lists and return it into a single linked list. So the given linked list is something 145, 134 and 26. We need to return is something like this. So this question is not very much difficult. I would say this is not um, a upper difficult level question. It is difficult. I'm not saying that it's not difficult, but if you if you have some intuition on how to approach this, you will be able to solve it very quickly. So we are given 3 linked list or multiple linked list will be given. I'll just have to iterate and I'll keep it in my priority queue based on its value and its node. This circle will denote the node and this will denote the value. So on the priority queue we'll keep it in a priority queue based on the smallest value at the top, and we'll sort on the basis of the smallest value. So we'll have something like this, 1 for the second, and 2. So this node and this one are different. Let me give a separate different circle so that we will be able to understand. This is this circle, this node. So after picking, we in priority queue it will be sorted on the basis of the smallest at the top. So we know that this is the smallest one. I'll just link this. I'll create a dummy pointer. Maybe name it as dummy. This will connect this one with its next, and one of my iterator will be here, and this will be popped. Its next value will be pushed in my value. So 4 will go at the bottom and its node value will be this. Now this will be popped and will be connected over here, and its next value, that is 3, will be pushed. Now this will be popped, this will be connected over here. Now my IT will also go here. Its next value will be connected over here, 2, and its 2's next value 6 will be pushed. Sorry, 6 will be pushed. So similarly way, now my top will denote. So top will have this as a value. So this will be popped. 3 will be connected. My IT will go here. 3 will be connected after this, and its next value will be pushed, 4 with 4. Now 6 will not be pushed. This 4 will be pushed after this. So 4 will be here, and there is no value next to it. It's null. So will not push anything. We also have 4 over here. So we'll connect 4, and its next value is 5. So we'll push 5 with node value 5. Now again priority queue will keep it sorting at the top. So 5 values will be. So on the basis of this we'll be able to solve this question, and the time complexity that it can go is n log n, and the space complexity will be O of n, because we'll be keeping all the values in a priority queue one by one. So this way we can solve this question. I'm not going to solve this question because it's not very much hard. If you can try by yourself. If you'll get some problem, let me know. I'm here only, so I'll solve this question again. Okay, so let's go and solve this question. The question says you are given two integer array nums1 and nums2 sorted in non-decreasing order and an integer k. Define a pair UV which consists of one element from the first array and one element from the second array. Define a pair UV. Which consists of one element from the first array and one element from the second array. Return the k pairs u1 v1 u2 v2 uk vk with the smallest sums. So okay, we see 1 7 11 2 4 6. The first three pairs are returned from sequence 1 2 1 4 1 6. 1 2 1 4 1 6 7 2 7 4 7 6 7 6 11 2 11 4 11 6. So based on some value they are sorted. So 2 plus 1, that is 3, 5 7 9 11 13 13 again 15 and 17 and I need to return top 3 element. So one approach we can what we can go for is a n square approach. Just pick one element from here and iterate over all the elements, and whatever the sum is, store it somewhere in a priority queue and return it. So that is one way we can approach that. The other way we can do is with the help of some comparison. Means nums1 and nums2 are sorted array by default. So we know we have 1 7 11 2 4 and 6. These are the elements that we have. Now even if we compare if we compare 1 with 2, 1 with 4, 2 with 7, so out of these three, which one is the smallest? I'll pick that and I'll move that index to the next one. Can we do that? Okay, if we go from behind, what we can find? Now if we go from behind, we know that there's one thing that I am 100% sure, that these two sum will be the maximum, and if we are starting from the bottom, we know that these two sum will be the smallest. I can this and this and this, or from bottom also this and this and these two. So 1 and 2 will be inserted in our answer, and the comparison will go to the other two values, this and this, this and this. So 1 and 4, which is giving me 5, and 2 and 7, which is giving me 9. So obviously this one is smallest. So I'll move like this is my iterator 1, it1, and this is my it2. So this is the smallest one, so I'll move my pointer to here, it2, and I'll keep this in my answer 1, 4. Now these are the two positions where my iterators are lying right now. So the pointer is this plus iterator 2 plus 1 will be compared, and this plus this will be compared with each other. So 1 plus 6, that is 7, and 7 plus 4 will be more, so 1 comma 6 will be, this is smaller, so my iterator 2 will move one step forward, will go here. Now k is finished. Are we 100% sure that k, it might be possible that k is greater than total values? And if suppose they both are equal, if the value is here 2 and the value here is 1 again, so in this case what we will do, we'll move any of the iterator I can move. Either I move this or I move that. Let's try and solve based on this approach. So what we have, will be having iterator 1 which will be pointing at index 0, and iterator 2 which will be pointing at index 0 of nums 1 and nums 2. Iterator 2 is for nums 2 and iterator 1 is for nums 1. Now I know this, I need to find the smallest, and for the largest I just have to go from backward, and the same thing I have to follow, and I just have to go from backward. And now for the smallest I just have to go from start. It's already given that the nums 1 and nums 2 are sorted in non-decreasing order. So while k is present, I'll create a resultant vector which will store my result. So in my result I'll push back nums 1 of IT1 comma nums nums sorry, okay, nums2 of IT2. So these both will be kept in our answer. Now I need to check if IT1 is equals to nums1 dot size minus 1. If this is the case, then IT2 plus plus I'll increase. Else if IT2 is equals to nums2 dot, if they both have reached to the last index, if any of them reaches to the last index, I won't be able to compare to the next value. So what I will do, I'll just simply move my other iterator. Else if they both haven't reached at the last position, then there is a possibility. So it will come here. Now if sum of means if nums1 of nums1 of IT1 plus nums2 of IT2 plus 1 is lesser than nums2 of IT2 plus nums1 of IT1 plus 1. If this is the case, this value is lesser than IT2 plus plus will be as IT1 plus plus. And at last I'll return my resultant. Let's see. Okay. Okay, so the first case succeeded, the second case also succeeded. Let's submit it and see if we are missing anything. Okay. Oh, it failed on the second test case only. Okay. 1, 2, 4, 5, 6. And the second test case is 3, 5, 7 and 9. Now what we were doing is we are pushing it in our answer, and then we are comparing these two. So 5 plus 1 is 6 and 3 plus 2 is 5. So my iterator IT1 will move here, IT2 will stay as it is. So the answer is 3 comma 2. 2 comma 3. Now the values comparison will be this and this, but not this, right? But in at this time 3 plus 4 is 7, 1 plus 5 is 6, so this would have been in our answer, that is 1 comma 5 and not 2 comma 5 or even 4 comma 3. Okay, how are we going to handle this? We need to somehow handle this also. One even I am moving the iterator, but there might be some value that is in the past. Means the value that we are leaving behind, we don't have to leave that value behind. If there is some value that we are leaving behind, we need to push it in our answer. That will be the next answer, might be possible. So this is my IT1, this is my IT2. We compared this with this and this value with this value. 1 comma 5, 3 comma 2. Now we know that 3 to 5, this value is going to be my next answer. This value is going to be my next answer. even if we have used that element before, I might use that element again. Okay, so in this case I'll keep something like a priority queue, which will help me in implementing this part. So let's keep a priority queue which will have some and corresponding values, IT1 or IT2. So initially 1 3 will be pushed in my answer. That will be one of my answer, that's for 100% sure. If that is already in my answer, I won't be doing it. What I'll do, I'll cross add both sum, both, so 3 to 5, that is 5 sum with 2 comma 3 and 1 comma 5. Six with 1 comma 5. So I have the smallest value, which is 2 comma 3. So the value which is smaller will give me a bigger value. So IT1 is smaller, so I'll move IT okay, let's do it something like this. Let's think some it will be similar, but the approach might a little change. I have a sum of 1 plus 3, that is 4. I'll the indices is, let's call 3 4 0 1 2 3. So these are the indices, so they both are at 0 0. So I'll pop this out, I'll keep this in my answer, the value present at this indice and indices, and the value present at this indices will be kept in my answer. So 1 and 3 will be in my answer. Now the next thing what I will do is compare with its cross values. So we'll get 3 2, that is 5 with 1 comma 0 as our indices, and 6 with 0 comma 1 as its indices. Now this is minimum, so I'll keep 2 comma 3 in our answer, and 1 comma 0 1 0 I'll cross multiply with this. So this plus this and this plus this. So 2 plus 5, that is 7. 7 with indices 1 comma 1, and 3 plus 4, 7 with indices 2 comma 0. Now I have a value of 6, which is 0 and 1, 0 and 1. 0 and 1, that is 1 comma 5 will be pushed in answer. So now 0 and 1, its cross value will be added. This will be added and will be kept in our priority queue. So this way will be our approach will be, I hope this should work. So I'll keep a priority queue. Priority queue will contain 3 things. And based on the first value, we'll be sorting it. So let's make it a vector. A vector int I need to keep the smallest value at the top, right? So vector int while k minus minus we need only those 3 values. So remove this. I don't want this. So initially I'll push in my pq dot push nums of 1 of 0 plus nums of 2 of 0. That will be sum with 0 comma 0 as the indices. Correct. Now in my result I'll it1 will be pq dot top 1, it2 will be pq dot top of second. And result I'll push back directly it1 comma it2. So in result I've already pushed it1 and it2. Now I need to cross add. So if it1 plus 1, this is lesser than nums dot size and it2 plus 1. So if it1 plus 1 is lesser than nums dot size, that means I can go here. So what I will do is pq dot push nums of it1 plus 1 with it1 plus 1 and it2 as it is. Now if it2 plus 1 is lesser than nums 2 dot size, this will be nums 1 plus nums 2 of IT2 nums1 of IT1 plus 1 plus nums of IT2, IT1 plus 1 and IT2. If IT2 plus 1 is lesser than nums2 dot size, so it will be very much similar. Nums1 of IT1 plus nums2 of IT2 plus 1. IT1 will go as it is, IT2 plus 1. Okay, now let's see. Oh my god. I need to nums1 of IT1 nums2 of IT2. Okay, this was, let's test this test case also. Perfect. So the third test case is also working perfectly. We are going 10 to the power 5, that means n log n is accepted, so it should be accepted if there is no error. Okay, but why? Okay. There are some repeated values. Okay, the sum is coming, is repeating itself. I don't want that. How can we stop the repetition? I have 1 comma 3, so that's 1 comma 5 and 3 comma 2 will be pushed. Then we have 1 comma 4, so 1 1 comma 5, 1 comma 7, and 5 comma 2 will be pushed in our priority, but 5 comma 2 is already there, so I don't have to push it. So if it is already there, then we don't have to push it in my queue. So I need to check whether it is already there or not. For that, what we can do, we can we can keep something which will help me in not pushing in my queue the same value as again. I can keep a set of string to stop repetition. So there might be a repetition. Now if ht dot find let's make a key. Key will be nothing but indices, correct? So to string it1 plus 1 to string it2. If ht dot find key is equals to ht dot n, that means this key is not present. So we'll push this and as well as ht dot okay. Now test case 4 is also I'm not inserting in my priority queue with the same indices value. So let's submit now. Hopefully this time it should be accepted. Great, but it is taking a lot of time. Already I had solved this question, I don't know. Okay, yeah, I did solve with priority queue only, but how are we handling this? Oh my god. So with 0th index I summed all the values. Okay, this is also not wrong, but maybe it will not come in mind when we are solving it for the first time. Okay, so we were able to solve find k pairs with smallest sum also. This is great. Finally, we are mm, able to go away with two only till now. Maybe I'll try to solve more and as quickly as possible for the rest of the part. Let's take a break, of a lunch break, and after lunch break, we'll go back again and we'll solve more questions. Okay, so hopefully see you after not 60 minutes. Let me change it to maybe let's reduce 50 minutes. See you in 50 minutes. Bye bye. I'm sorry, I'm back. It's a little late. I know I'm late. No problem. Let's go. Let's solve some more question pattern based. So the question is top k elements. Any problem that asks us to find top smallest frequent k element among the given set falls under this pattern. Okay, top k element. The best data structure to keep track of k element is heap. Okay, we can use heap to keep means priority queue, some kind of. This pattern will make us make use of the heap to solve multiple problems dealing with k elements at a time from a given set of a given element. The pattern looks like this. Insert k elements into the min heap or max heap based on the problem. Insert k elements into the min heap or max heap based on the problem. Iterate through the remaining numbers, and if you find one that is larger than what you have in the heap, then remove that number and insert the larger one. Okay, so based on min heap or max heap, based on the question, we need to decide which one to take, whether to take a min heap or whether to take a max heap. Correct. Correct. So let's find top k frequent numbers. Let's search top k frequent element, frequent words. Okay. Let's open this also, and maybe this also. Given an array of string of words and an integer k, return the k most frequent string. Return the answer sorted in frequency from highest to lowest. Sort the word with the same frequency by their lexicographical order. So I have words. I love lead code. I love coding. So k is 2. Two most frequent elements. So I can see I occurring twice. Love occurring twice. So if there are multiple same, then we need to make it in alphabetical order. Sort it on the basis of alphabetical order. Okay, let's try for the follow-up question, because I think we can go for n square method also, iterating everywhere and finding the answer, but doing iteratively is not going to give me the optimal answer. Maybe I can go for some other approach. So what can we do? We can use O of n log k, means k top element. We have to sort so for this we need to keep a most frequent. I know that if frequent word comes, then we need to solve it using that approach. Using some min heap or max heap. The only thing that I need to handle is if there are multiple occurrences of the same, it should be sorted on the basis of on basis of lexicographical order. Right. So for this we can use a priority queue. Okay, first to solve this question, it's very similar to the same, but the only thing is it's given string over here and not an array. Okay. Top k frequent elements. So I'll keep a priority queue with ourselves, which will have integer value. Which will be nothing but pq. Priority queue will contain top k frequent element. Your algorithm time complexity must be better than O of n log n. I can even take space. Correct. So what if I take some space, say 10 nums value okay, nums value is also ranging from negative to positive, so I can't take array. So if I keep the count, if I keep a count, let's suppose what we do is we keep count of 1 as 2, count of 2 as 2, count of 3 as 1. Correct. So 1 has a frequency of 3, 2 has a frequency of 2, 3 has a frequency of 1. Now let's simply iterate over this array and find the top k frequent element using priority queue. So it will be n log k. So what I will do is I have the frequency as 3. So this is in my priority queue. If any other value comes, let's suppose we kept 2 over here for instance. If a new value comes that has a frequency of 3, This is 2 value. Now a new value comes, that is 1, which has a frequency of 3, which is greater than. So what I will do, I'll keep the smallest value at the top. So 2 is the smallest value. I know this is greater than, so I'll pop this and I'll push 3 as 1 in my queue. I have the next comes is 3, which has a frequency of 1 and which is smaller than. Okay, so it will be not very much difficult. We can use unordered map initially to keep the frequency. Iterate for int I equals to 0, I is lesser than plus I. Frequency of nums of I plus plus. Now this priority queue will do what? Will keep the largest value at the top, but I want the smallest value at the top. Greater. So while it is not equals to frequency dot end, until and unless it does not reach the value. Okay, I need to keep its frequency with its value, so this will nothing but a pair of int comma int. So int frequency is pq dot top का first value is pq dot top का first, pq dot top का second. I don't even require value for now. I just need to keep the frequency at top. So I kept the frequency. I popped the value. Now I need to check the frequency that is coming with the IT. New frequency is equals to IT dot. Now if so one thing that I need to, if my pq dot empty is true, that means priority queue is empty initially. I just have to push pq dot push it second will be my frequency and it first will be my value, and I'll simply continue in that case. Now after second value, my IT will increase. After second value, f is equals to pq dot top. I got the lowest value at the top, and the new frequency is IT ka second. I just need to check if the frequency of this element is, if the new frequency that is coming is greater than this frequency, I'll simply pq dot pop. or even one more case, if pq dot size is lesser than k. If pq dot size is lesser than k, I'll directly do this. If it is equals, then here comes the problem. So if a new frequency is greater than the frequency that we already have, so I'll pop that out. I'll push this new frequency with the new value, and at last I need to return result. This is my result. While priority queue is not empty, result dot push back pq dot top second. The answer should be in any order, right? pq dot top ka second, and also I'll pq dot pop. Simply return result after this. Let's see. 1 2 or 2 1 doesn't matter. Why my output came out to be 2 2? 1 with frequency 1, 2 with frequency 1, it is equals to frequency dot begin. And I have a priority queue which will keep the highest frequency at the top. No, this will greater will sort with the lowest frequency at the top. So if pq dot size is lesser than, so pq dot push it ka second and it ka first is my value, and it ka second is my frequency. And continue. Oh, okay. My bad. I didn't increase my pointer over here. Great. So this was nlog k. This question is exactly same. I would say in this I will use hash map and keep all the frequencies, and on the basis of frequency I will sort. Now if the value is coming out to be same, then I'll check which is smaller, if the frequency is, if the string is smaller or not. If it is smaller, and then I'll then directly so I'm not going to solve this question. This will be easier one. So I'll directly jump to the KV merge is complete, top K element is complete. Let's call modified binary search. Okay, so this question is really good. This technique is really binary. Modified binary search comes in lots and lots of question. I have already seen binary search question coming in many of the interviews and also in many of the contests. This modified binary search. So in this today we'll be solving this modified binary search only. So let's see. Search in a sorted infinite array. Modified binary search is nothing but a simple binary search, but a just slight variation. So if you know binary search, you'll be able to see how the things are going on. So let's solve this. Where it is? Search in a sorted infinite array. Let's see. Search in a sorted infinite array. Infinite sorted array. Find in infinite sorted array. Okay. Okay, so the question says that suppose you have a sorted array of infinite numbers, how would you search an element in the array? So this question has come in Amazon interview experience. Since the array is sorted, the first thing that clicks into my mind, into my person's mind, is binary search. But the problem here is that we don't know the size of the array. If the array is infinite, that means we don't have a proper bounds to apply binary search. So in order to find the position of key, first we find bounds and then apply binary search algorithm. Now we need to find bounds if we are applying binary search algorithm, but here I can see there is no bound. It is an infinite number, infinite sorted array. How will I able to find the bound? If the array is infinite, that means we don't have a proper bounds to apply binary search. So in order to find position of the key, first we find bounds and then we apply binary search algorithm. Let low be pointing to the first element and high be pointing to the second element of the array. Now compare key with high index element. If the key is greater than high index element, then copy the high index in low index and double the high index. Oh, if it is smaller, then apply binary search. Oh, okay, it's a nice approach. If there is an infinite array size, then how are we going to apply binary search on that. So what it is saying, I'll explain you over here only. It is saying that find position of an element in a sorted of infinite numbers. So if we know that we have an infinite numbers on a plane, from maybe all the numbers are positive for now. Let's suppose all the numbers are positive, and we have it this as infinity. Now what actually we are doing, let me just make it a little black so I'll get a better idea. So this is my 0, this is my 1 2 3 4 5 6 7 8 9 10 dot 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 dot. Suppose we have to search 100 200 something like this. Suppose we have to search an element maybe 51. So we have to search an element 51 here. So how are we going to search 51 here? So for searching 51, what we will do is we will keep 2 pointers, the left bound and the right bound, at 0 and 1 initially. So we'll compare our element, that is 51, with our right bound, whether the element lies before this element is something like this. So currently my right bound is 1, my left bound is 0. So 51 is not lesser than 1, correct? So what we will do, we will move my left pointer to 1 and my right pointer twice of right. So it will be at 2 position right now. Now 1 and 2, I can see 51 is not between 1 and 2. So I'll again increase our left pointer with right pointer, and right pointer will be twice of left pointer, that is 4. Again it is not there, so I'll keep my left pointer here and right pointer will be 8. Again it is not there, so my left pointer will be 8, right pointer will be 16. Again it is not in between, so left pointer is 16, right pointer is 32. Again not in between, so left pointer is 32 and right pointer is 64. Now we can see that our value ranges between 32 and 64. Now what we need to do, now we will move our left pointer and right pointer. So we know that we can now we can directly apply binary search, because we found the lower bound and the higher bound. So we'll find mid, simple. Now binary search will go on. We'll find mid, 64 plus 32, 96 by 2, which will be 48. And if the value is greater than 48, then my lower pointer will move to 48 and higher pointer will be 64. So now we can apply binary search approach here, and we can find our answer. So how many steps it required? 1 2 3 4 5 6 7 steps here, and after this these mid steps and moving my higher and lower pointer. So it will somewhere near 8 or 9 steps will be required to find my actual answer. So it's a very nice approach, nice way. How we are finding the lower bound and higher bound. Great. There is one more question, which is cocoa eating bananas. This is one of the most hmm, frequent question that where we can apply binary search and solve good questions, good binary search questions. So cocoa eating banana is one of the good binary search question. If you want to use this binary search question, then you can surely try this out. So this was one of the modified binary search. Now let's look at subset, then 2 hips, then tree DFS, and we are good to go. So let's go for subset problem. Okay, so this is actually a good way to I would say practice your recursion questions, recursive question. We can also go for breadth first search approach or depth first search approach. So a huge number of coding interview problems involve dealing with permutation combination of a given set of elements. The pattern subset describes an efficient BFS approach to handle all these problems. The pattern looks like this. We are given a set, start with empty set, add the first element to all the existing subset to create a new subset, add the second element to the existing subset, one three five three 153. So it is saying that we need to find all the subsets and it should not contain duplicate subsets. So we are given 1, 2, 3. So this is an open bracket. One empty bracket will be there. Initially one will be inserted. Now in 2 we'll take 2, we can directly insert 2 as it is, or also we can check this is 1, I'll insert 2 with this 1 and insert it over here, 1, 2. I'll take 3 and I'll also insert this 3 in 1, so 1, 3, 2, 3 will be one of my answer, and then 1, 2, 3, and then 3 as it is. So we can return the solution in any order. So this way we can find the solution for this. So subsets is not hard. It's a very typical type of problem that you can solve. You just have to iterate back again, and also it is given 10, so you can directly create your answers. You don't have to do anything. So that's just fine. So So I won't be solving this uh, subset problem. If you'll face any issue, let me know. I'll help you in solving this problem, but it is not very much difficult to solve these kind of problems. So the next question is string permutation by changing case. Is it letter case permutation? Okay. Now in here what I need to do is I need to print all the permutations of a string keeping the sequence but changing the cases. So the naive approach will be obviously going for a recursive change the case and do not change the case. So this way we can do the recursion and we can find the answer. This will take a time complexity of 2 to the power n obviously and space complexity of O of n. Method 2 would be for a string of length and there exists 2 to the power n maximum combination. We can represent this as a bitwise operation. The same idea is to question print all subsequences. So why would I go for this approach if this is taking a more time complexity n into 2 to the power n and this is only taking 2 to the power n, so why? Now transfer every letter individually to be lowercase or uppercase to create another string. Return list of all possible string we could create. Return the output in any order. Let's try and solve this question. We need to return all the possible combinations over here. So what all possible combinations can we do? We first we need to check whether that is a character or not. If it is not a character from A to Z within A to Z, then if it is a number is digit. There was a method called is digit, what I remember. We could return the output in any order. Okay, so let's create a vector string v maybe resultant, and I'll return this result. What I'm doing, so I'll simply solve. I'll give this as, I'll give the index, I'll pass the resultant. Now what I will do is I will possibly take all the possible um, way. Uh, so I'll be returning void from here. I don't have to return anything because I'm already taking it in my parameters. String ampersand s int idx. Vector string if my idx is greater than equals to s dot size result dot pushback s, and I'll simply return from here. Now if it is not, I need to check whether वो is digit है. There is a method called is digit. I remember is digit in C++. And one more, two lower. So if this character is a digit, so first we need to convert it into 2 lower and then convert it into 2 upper. So if is underscore digit, no, it's not underscore digit. If is digit s of idx, if not, then we'll have to go for 2 calls. First char ch is equals to 2 lower s of idx. Okay, will not it, does it return anything? It returns Oh boy. This is digit is creating some problem. Char ch is equals to s of idx. If not is digit. Hey, it never went inside. Oh, okay, okay, okay. If not, then I'll directly call this solve s of idx plus 1 with result as it is. That a1 b2 a1 b2. Okay, this upper didn't work. Okay. Oh, oh, okay. Or s of idx is equals to this, or s of idx is equals to this. Okay, now it worked. Fine, great. So this is not that difficult. It was only just I forgot. So now I remember this 2 upper, 2 lower, and is digit, all these methods. So this was a good question also. Fine, I think we were able to solve this subset problem also. So the in next after the break, I'll try with 2 heap and then 3DFS. These are the two left. Oh, great, nice. So let's do it. Let's go for a 10-minute break, and after that, when we come back, we'll solve the remaining two. See you after the break. I'm back. Let's solve some more questions. So we already solved many of the problems. Now the only left is two, that is two heaps and three DFS. So let's solve this. Two heap and three DFS question. So let's which one should I go for, 3 DFS or 2 heap first? Let's do akkada bakkada so sound like 2 heap, simple. Okay, no problem. I'll go with the 2 heap first. So 2 heaps is basically very specific type of question. Let's see what it says. In many problems we are given a set of elements such that we can divide them into two parts. To solve the problem, we are interested in knowing the smallest element in one part and the biggest element in other part. This pattern is efficient approach to solve such problems. This pattern uses 2 heap to find the smallest element and a max heap to find the biggest element. The pattern works by storing the first half of numbers in max heap. This is because you want to find the largest number in the first half. You then store the second half of numbers in min heap as you want to find the smallest number in the second half. At the time, the median of the current list of numbers can be calculated from the top element of the 2 heaps. We used to identify the 2 heap pattern. Useful in situation like priority queue and scheduling. Correct. If the problem states that you need to find the smallest, largest, median elements of a set, sometimes useful in problems featuring a binary tree data structure. Okay, correct. Binary tree data structure में you can use 2 heaps. 2 heaps are being used a lot in binary tree data structure. Okay, so so the question is find the median of a number stream. Let's see how can we use 2 stream. Okay, it's a good question. Let's solve this question. This will give us a lot of idea on how to approach the 2 heaps problem. Let's see. So the median is the middle value in the ordered integer list. If the size of the list is even, there is no middle value, and the median is the mean of the 2 middle values. If the size of the list is even, it's like 6, so 3 this side, 3 this side, then there is no middle value, and the median is the mean of the 2 middle values. So there will be this value and this value, these two will give me the median if it is even. If it is odd, then we know that 3 this side, 3 this side, 1 will be there in this side, which will be my median. So these are the 2 values, these are the 2 medians, and this is 1 median. For example, 2, 3, 4, the median is 3. So let's see. implement the median finder class. Median finder. Okay. Median finder is just a initialization of object. Cool. The second is void add num. Adds the integer num from the data stream to the data structure. Find median. So median will always be the two values sorted. Returns the median of the element so far. Answers within 10 to the power 5. 10 to the power minus 5 of actual answer will be accepted. So add num 1 is added. We have 1. We again add a number, that is 2. We find median. So we have two numbers which are even. So the median will be 2 plus 1 by 2, that is 1.5, correct? So 1.5. So the number ranging 10 to the power 5. So total calls will be made for add num and find median is 5 into 10 to the power 4. So each time we do not have to sort the values or do anything. So suppose there is a value 4, 5, 6 and 7. There is an array 1, 2, 3, 4, 5, 6, 7. So if I want to know, this is an odd, so this 4 will be in our answer. Now if I keep an even, for now, let's suppose we have even number of values. Now this 4 and 5 will combinedly make our answer. So there will be one heap that I need. There will be two half of this. I say this is my first half and this is my second half. So this is the top element and this is the lowest element in these two half. So this is the highest element, so I can keep a max heap for this, and I can keep a min heap for this. Now how our answer will be, if a value which comes, suppose a value which is 4.5, if this value comes after this, we know that the value is lesser than this 5, this max heap's value. If it would have been even equals to, if 5 comes, what should we do? We can directly move it to my min heap. If it is even equal, if a value which is greater than, if 6 comes, now what will happen? Okay, look closely. What will happen? If I directly push 6 in our this min heap, this will be 5, 6, 6, 7, 8, and this will be 4, 3, 2, 1. So if a value 1 comes, I'll keep this in my min heap, suppose max heap. If a value 2 comes, let's suppose I'll keep this in my min heap for now. This is my min heap. This is my max heap. So minimum at the top. If value 1 comes, it, it is inserted into min heap. If value 2 comes, which is greater than this value, so I'll insert it in my min heap only. Now if now I need to balance out also. The maximum difference between max heap and min heap should be at max of 1, not more than that. If the maximum difference is more than that, that means we need to do something. So then in that case I'll have to pop this off and push it over here. We need to balance it every time. So find median. Now the both size are same, so we will pick the top element from both, add and divided by 2. Now we again add a number that is 3. So 3 is greater than 2. I'll push it and now check the balance. The balance is fine. So if suppose 3, now comes 2. So if value is lesser than 3, again I have to balance it out. If max heap's value is more, keep it in min heap. If min heap's value is more, jump it to the max heap. I have to balance each and everything. So let's keep 2 priorities. Priority queue, which will contain integer value. This will be max heap, keeping the maximum element at the top. This will be min heap, keeping the smallest element at the top. Now add it in max heap and now balance, something like that. So what we will do is if any value, if any number comes, simply add it in max heap. Max heap dot insert this num, and now call a balance method, which will do the balancing part. Now this balance will do balance. Now if max heap dot size is greater than min heap plus 1, means if दोनों का difference is greater than 1, max heap minus min heap dot size If it is greater than 1, then we need to do something. Let's do it something like this. So what we will do is we will pick an element from max heap. Int element is equals to max heap dot top. No, min heap dot push element and max heap dot pop. Now median will be if max heap dot size is equals to mean heap dot size in this case will return double sorry. Okay, now there is something that is going wrong. This is my max heap, this is my main heap. What will happen? This max heap will contain value 1, then comes 2, so this will be shifted over here and balanced. So 1 2 and so 1 2. Okay, there is something that I am missing. What I am missing? where to insert this new value that is coming as 3. Now we have one half even and the second half even. 1 and 2 are even. 3 comes. If I put it in my max heap, it will come out on the top. If I put it in my min heap, it goes to the bottom. Nice. Now there needs to be some thinking. I have 1, I have 2. Now for inserting 3, now if when there is an odd value, then I need to know what to do, because in even value there's no issue. Min heap top and max heap top will always give me. Now but when there is an odd value, we know that the value is greater than max heap. So if the value is greater than max heap, it will surely be inserted after that. If the value is this is max heap, the value will be inserted over here. Now where to insert? Now this value will go here or this value will go here. How are we deciding this part? Where should it go? Three, then comes 4 and then comes 5. Even suppose I inserted it here, then comes 4 which is greater than this whole 4 here, 5 will be here. Now this time the answer is not 2, the answer is 3, which is this value. Okay, there is something. So the value, this value and this, even if it is 4, then I need to take this value and this value. This is min heap. So this is max heap. So 4. Okay, 4 will go at the top. Now 2 and 3. Even 1, 2, 3, 4 will fail. That means 2 should have been at the top. That means max heap should have contained 2, 1, and min heap should have contained 3, 4. Now if one more value comes, if I insert it over here, then it's fine. If one more value comes, 6, what should I do? If 6 comes, then 3 and 4 is my answer. Then I need to shift this to the right. Shift this to the right and push 6 in the min heap, 3 and 4. Now one more value comes, 7. So min heap contains my answer. If a value arrives as 2, now what to do? This should be adjusted in max heap, don't you think so? 3, 2, 2, 1. 4 and 3. 1, 2, 2, 3, 4, 5. 4, 1, 2, 3, 4. This should have been adjusted in. I inserted it in min heap, but it will go in max. Okay. If 1 comes, I insert it in my min heap. If 2 comes, I still insert it in my min heap. Now the difference is this, so I'll balance it out by moving 1 from here to here. Now 3 arrives. I inserted it in my min heap. Now 2 again arrives. I inserted it in my main heap, and now I need to balance it out. I moved this to here. So this is a max heap, right? So the value will be here. If 8 comes, I inserted it in my main heap. If 5 comes, h5 should be adjusted. 2 will be shifted here. 2, it will be 2 to 1, and this will be 3, 5 and 8. Okay, I'm pretty much sure that this will fail. I need to think something better. Knew that. Okay, the values can be negative also. Dot size. I'm sorry, my internet went down, but now it's up. If S1 and S2 they both are zeros, so I pushed it in simply in max heap. Else if num is greater than max heap dot top, if the value is greater than max heap dot top, push it in min heap, so it'll go at the bottom. Else why? If the value is greater than max heap dot top, so max heap contains maximum value at the top, right? That's what. Sorry. So max heap contain maximum value, the highest value at the top. If the value, this value is even greater than the value at the top, I'll push it in my main heap, so I'll go at the bottom. I'll push it in my max heap. So num is greater than max heap dot top, so I pushed it in min heap, else max heap. That's fine, but I need to understand why. Okay, let's suppose that this is done. Now the absolute value is greater than 1, that means we need to balance it out. Now if s1 minus s2 is greater than 1, that means s1 has a greater value. So s1 is max heap. So I'll pop element from max heap and push it in my min heap. Else I'll pop element from min heap and push it in my max heap. It's going very simple, but I just need to know if num is greater than max heap dot top, I'm pushing it in min heap, else I'm pushing it in max heap. Let me see. Store a half lower numbers. I just need to know if a value which is greater than max heap, that means if a value 3 comes, why are we pushing it in our min heap, at the bottom of the min heap? Let's dry run again. 1 comes, I push it in my max heap, suppose 1. 2, if the value is greater than this value, I'm pushing it in my min heap. Now 3 comes, value is greater than this, so push it in my min heap. If 2 comes, push it in my min heap. Now balance it out. So I'll pop from here, I'll push it here. If 8 comes, it's greater than my max heap, push it here. So 1, 2, 2, 3, 8. 2 is my answer. If 5 comes, greater than max heap, push it in min heap. Pop this and balance it out from here. If it is greater than, why can't we push it here? Can't we do this? Let's just understand. Let's push it here. If 1 comes, push it in my max heap for now. If 2 comes, push it in my max heap. Now balance it out. 1 comes here, 2 comes here. If 3 comes, push it in my max heap. Which will give me a wrong answer. So I'll have to push it here. If 2 comes, push it here. 1, 2, 2, 3. Still I have to push it here. Two one. If 8 comes, if 5 comes, push it in my max heap. And now pop this element and back. Now if if num is greater than max heap dot top, now balance. If min heap dot size, absolute value of min heap dot size minus max heap dot size is obviously greater than 1, then if min heap dot size is greater than max heap dot size, that means मीन हिप से एलिमेंट निकालो और मैक्स हिप में पुश करो और मीन हिप से पॉप करो, एल्स जस्ट अपोजिट, मैक्स हिप से एलिमेंट निकालो, मिन हिप में पुश करो और मैक्स हिप से पॉप करो. एल्स दोनों का सेम साइज है तो एल्स min heap dot size is greater than max heap dot size. If this is the case, then min heap dot top return करो else max unreachable statement. Max heap is equal to heap dot size min heap is equal to min dot size. Okay, find median from data stream. So this is a nice question. Okay, let's see what he's doing. Use max to heap min heap. We need to balance the size between max and min heap while processing. Hence k elements. If k when adding a new number num into our mean finder, firstly add num to max heap. Now max heap may contain the big element which should not belong which should belong to min heap, so we need to balance by removing the highest element from max heap and offer it to min heap. Now min heap might hold more element than max heap. In that case we need to balance the size by removing the lowest element from min heap and offer it to back to max heap. Max heap dot push max heap dot push num. I'm pushing it always in max heap. Now min heap dot push max heap dot top and max heap dot pop. So this is making sure that we always keep the elements maximum in the max heap. So it is pushing all the values in max heap, and in the top element it is pushing it in his min heap and removing that element. Okay, fine. So this was also one of the good question. Okay, let's take a 10-minute break, and after the break we'll go with the last pattern that we have for today, which is tree DFS. Cool. We are very close to finishing. Let's go for 10 minutes break, and when we'll back we'll start some more question. Let's go. So let's go for the last pattern that we can have is tree DFS. Is based on depth. It's a depth first search traversal of tree. You can use recursion or stack for iterative approach to keep track of all the previous parent node while traversing. The tree DFS pattern works by starting at the root of the tree. If the node is not a leaf, you need to do three things. Decide whether to process the current node now, that is pre-order, in order, or post-order. So we already know what is pre-order, in order, and post-order. If you don't know what is pre-order, in order, and post-order, I would suggest that you should go and watch some videos based on pre-order, post-order, and in order traversal. I'll just give you a brief idea that in order traversal will give you if it is a binary search tree, then it will give you a sorted array as a result if you do an in order traversal. So it's simple. If you are given a tree and you need to you are asked to draw in order, pre-order, post-order DFS. If the problem requires searching for something where the node is closer to a leaf, problem featuring tree DFS. All path for a sum of path numbers. Let's see, all path for a sum, path sum maybe, and all path sum of path number, all path for a sum. That will be path sum 1 and path sum 2, I guess. Let's solve this path sum 2 and path sum 3 question and let's see how we can do it. So we are given a root of a binary tree and an integer target sum. We have to return all root to leaf path where the sum of node values in the path equals target sum. So given the root of a binary tree and an integer target sum, okay, return all root to leaf path where the sum of the node values in the path equals target sum. Each path should be returned as a list of the values, not node references. Okay. A root to leaf path is a path starting from root and ending at leaf. A leaf is a node with no children. So I need to find the path from root to leaf and return whose all values are equals to target sum. So this is where this will be very simple, not going to be very hard DFS approach that we are going to apply. So we'll directly we'll create a resultant vector which will store our results, and we'll create a answer vector which will keep our answer for that, for specific particular path. So I have root, I will be passing my target sum also, and my answer and my result. So these so it will return nothing. I have a tree node root and int target sum, and this is a vector integer. This will also be passed by reference. Okay, vector if in, if in not root, so I will return from here, but if target sum is equals to 0, then in my result I'll push back my answer. So what I will do, I'll call my solve with root left my target sum minus root का val answer. So answer dot push back and result will go as it is. Solve. No. If not root return, let me push back now. If it is root, and if root if not root left and not root right, that means this is my answer. So now I'll paste this. If my target becomes 0, okay. Root left target sum is this. I have not passed answer. So these will do our job. If I submit, so it's passed. This was not that difficult. Now let's see path sum 3. Given root of a binary tree integer, return the number of paths where the sum of the values along the path equals target sum. The path does not need to start and end at the root or a leaf, but it should go downwards, that is traveling from parent node to the child node. Okay, so in this case I need to find the path, it should not start from root leaf to it should not start from, it might not start from root and not even ends to leaf. So I need to find all the path and count all the paths in that case. Okay, so how are we going to do or solve this? Let's see. I have 10. I go to 5. I go to 3. I go to 2. I go to 1. So this is my tree now. This is my target sum that I need to create. Target is 8. I need to make 8. So 10, let me keep in this path, correct. I am traveling in this path. Okay, so I have a 10 value with a frequency of 1. So 5, 3 and 5, suppose. So 10 minus 8, that is 2. Have we seen 2 in the past? No. We add 5. So total sum is 15. Now 15 minus 8 will give me 7. Did we see 7 in the past? No. So we keep 15 as 1. Now we go 18. 18 minus 8, that is 10. Have we seen 10 in the past? Yes, I have seen. Its count is 1. So I'll add in my answer plus plus, that is 1. So 1 will be added in my answer. Now we'll move again. 5, add 5, 23. 23 minus 8, that is 15. Did we see we'll add 18 also. We saw 15 in past, yes. One time. Remove this, we'll remove this, we'll remove this. From here I'm jumping, so no, will not remove the last. These two will be removed. 18 it. Uh, 10 minus 3, that is 7. 7 minus 8. Did we saw negative 1 in the past? No. No. 7 plus 11, that is 18 minus. Okay, we can do it with the sum. I just need to know how are we handling. How are we handling the summation? Should we keep a map for this? And every time I need to remove values from that map. So it might be possible that there are values. Suppose 10 comes twice. 10. Then it comes minus 10 and then again 10. And then comes maybe 8, direct 8. So 10 count 1, minus 10 0 count 1, 10 count 2. Now 8 comes. We saw 8. So there is one value that is this, and the other value is this. This will also contribute to contribute in my answer, right? This is sum of this also count. Whatever the count it contains will be. Sum store. I'll call solve with root my target sum with sum store and actual sum. So we'll do solve. We have 3 node root plus sum store sum. But now if sum minus target sum, Some store if it is there it'll add. And now so I'll have to add like if my target is 10 and sum is sum comes out to be 10 and 10 minus 10 will give me 0 but there is no 0 present, so in that case it'll so sum store 0 with 1 target sum store sum will be sent directly after and then to root now after coming back I'll reduce some mine because I have to go back and also some store of some minus just a second, I need to do this before if sum store sum is equals to 0 sum store dot so for first case and for the second case also I'm able to submit. Let's see if there is any wrong test case. That let's use this test case. So the third test case is also passing. We are getting output 4. Let's submit it and see if we are missing anything or doing anything. Okay. Okay, it my number 16, it is saying I cannot make it. Okay, so the sum needs to be long. For that, this also to be long. For accepting here, this also to be long. Use this test case. Now it is working. Great. So we were able to solve both of the question, path sum 2, path sum 3, and finally I can say that we are also able to see what tree DFS is. We can even solve these tree BFS question also using tree DFS, but it will take some time, or maybe you also can try to solve this tree BFS question in place reversal of linked list. So what we did is we solved all the 14 patterns that we can see within the time frame that we had. So we solved sliding window, good questions of sliding window. If you want, you can also try the sliding window. I might I'll just ping this to the chat box So hopefully if you'll see, you can try this also. So fast and slow pointers, we saw fast and slow pointers, how using fast and slow pointers we can go to the midpoint of any linked list, or even we can find a cycle, and at what position that cycle is. We we can use fast and slow for that. We solved use merge interval questions. In merge interval also, how we saw that there are many overlapping cases, and how those overlapping cases are being handled using two pointer approach in merge intervals. We saw cyclic sort. In the cyclic sort, when the numbers are uh, within a fixed range, it was given that if an array is given and the numbers are within a fixed range, so we need to, and we need to sort that array. We can go for O of n approach also to sort that array, or even we can go for we can also find a cycle in this array. How to find a cycle, everything was really clearly clear, and there were very good questions based on this we solved. And then we solved in place reversal of linked list. Means we don't have to create a new linked list every time. We just have to use the same linked list and solve uh, in place. Either we have to sort it on the basis of k, or on the basis of some given range, or we have to reverse all the arrays. So we have to do those all things in place. So we saw that also, how to do that. Then we went for a tree BFS approach, where we solved some zigzag traversal, and we also solved a very good question of this tree BFS approach. I don't remember the exact question, but it is present in my previous video. So if you want, you can check that out. So today we solved a tree DFS question. Tree DFS also is not very much difficult. We just need to see or figure out how we need to handle all those questions, on how my recursion is going, how everything is being handled in one place. So tree DFS is also very good. Two heap problem, we solved this number of stream question. This was really a good question, where we used two heap for separating out the minimum max heap and the min heap part in a stream of array using two heap. We saw subset problem, where we need to find all the subset that are present. So this was also very simple and very easy question, how we can find all the subset. Then we saw some modified binary search. So this was really good, where we need to find a value in a sorted infinite array. We are given an infinite array, and we don't know how to solve how to where to find that value, whether it is present or not, something like that. So this also question was very good, very good. You can try this question, or even you can check my video out. You can go back and see how I solved this sorted infinite array question. There are few more questions based on this binary search, that is rotated sorted array, find value in rotated sorted array, cocoa eating banana, and few more questions that are very good in this binary search question. The next is top k elements. We need to find the top k elements using priority queue, and even we don't have to go for n log n approach. We have to minimize it to n log k approach. So this was also very good question. Now k-way merge was also very good, where we were given a linked list, and we need to sort that linked list in place. We don't have to use extra space for creating new nodes or something like that. So this was also very good question, k-way merge. And finally we saw the topological sort, where we need to find some ordering in our graph. in that case we went for a topological sort, and we this task scheduling question was really interesting question. So you should try this task scheduling question. I would recommend you to try this task scheduling question, and if you didn't get any solution, or if you didn't understand, you can go back to my solution, or even you can ping me, or you can comment down below, and I'll explain the question again in the next stream, or maybe in the chat. So finally we were able to solve all the 14 patterns. So I think this was very informative session that we did in the past 2 weeks, and in the next session I'm thinking of going for some random question, and attempting all very new questions where we can apply all these patterns, and we can see how everything is working, and whether we improved our skills or not. So if you like this video, then do like and share, so that we can grow more, and we will be able to solve more pattern based question. Okay, so it was a great discussion. Now I think I'll take a break because we have a contest at 8. So now I'll take a break, and at 8 p.m. I'll go for the contest, and hopefully I'm not able to stream that contest because it'll give me a copyright, or even my account will be banned, so I won't be streaming that live here. But for sure I will be giving the contest, and I'll be solving the question, and then I'll post it on the LinkedIn, whether how much question I was able to solve and everything. So yeah, so that's it for today. Hope you enjoyed solving DSA questions. So see you in the next stream, maybe tomorrow or maybe next Saturday. Thank you. Bye bye.